When we think of faster-than-light travel, one term instantly comes to mind: warp drive. Immortalized by science fiction, especially in the Star Trek universe, warp drive represents humanity's dream of traversing the vast cosmos in a matter of moments. But what exactly is warp drive, and could it ever become real? In the fictional world of Star Trek, warp drive allows starships to break the light speed barrier by warping space-time itself. Instead of moving through space in a straight line, these ships compress the space in front of them and expand the space behind, effectively riding a wave through space-time. This means they're not technically moving faster than light, they're changing the space around them. A central component in this mechanism is the warp core, powered by a controlled matter-antimatter reaction, regulated by the iconic dilithium crystals. It's a brilliant piece of storytelling that captured the imagination of millions. But warp drive isn't just a fantasy. In 1994, Mexican physicist Miguel Alcubierre proposed a real theoretical framework for what he called the Alcubierre drive. Inspired by Einstein's general relativity, this concept involves a spacecraft sitting inside a warp bubble. The bubble would contract space in front of it and expand space behind, effectively moving the craft without breaking the laws of physics. To an outside observer, the ship appears to travel faster than light, while inside the bubble, time and space behave normally. However, there's a catch. Creating such a warp bubble would require what's known as exotic matter, a form of matter with negative energy density. Not only has this never been observed, but the amount of energy required could rival the mass energy of planets or even stars. Some recent studies have suggested ways to reduce the energy requirements, but we're still far from a practical solution. Beyond the math and theory, the idea of warp drive touches something deeper: our desire to explore, to reach out into the unknown, and to cross the infinite gulf between stars. Today, scientists continue to explore the boundaries of theoretical physics, and while warp drive remains speculative, it fuels the imagination and motivates us to push the limits of technology. So, will we ever build a warp drive? No one knows for sure. But the journey toward that answer may lead us to new breakthroughs in science and engineering. After all, many things we once thought were pure science fiction, like video calls, artificial intelligence, and robots, are now part of everyday life. Until then, warp drive remains a fascinating blend of science and imagination, a symbol of our endless curiosity and hope for the future of space travel.